Good morning, everyone. Welcome to the first session of the day. I'd like to introduce myself in a moment along with my co-speaker, Nick. But first, what are we here for today? Apart from talking about how to escape the AI hype cycle and what that means, it's really understanding two things. Understanding what goes into any kind of AI algorithm or data science application and whatever value you get out of it through either outputs from your algorithms or from the business processes you take to get there to maximize sort of the impact you make. Those are the two things, those are two themes I'd like to touch on today. Just quickly who I am. I'm a couple of things. I'm CTO for a company called AgriCompass. I've recently had a bit of success in climate science for AI. I'm at the University of Oxford. A few things. I used to be a data science and architecture consultant as well. And I'm part of a new consultancy in Saudi Arabia called Sail Ventures, which touch on everything from agri-tech and electric vehicles to health and AI and data strategy. I believe that a copy of our slides will be up on the website in the next couple of days, and you can reach out to us on Twitter if you've got any questions that you don't manage to get in during the session.
Hey, my name is Nick. I'm part of a company here based out of the Silicon Valley called Hive. I'm the technical director of client solutions, and here at Hive we are focused on making AI accessible to pretty much any company that wants to use it. So I'll be talking in more details about some of the services that we've built and how some of our essentially learnings can be applied to the Saudi market as well. And this is kind of a high level overview, but our main business is comprised of two parts. One is a data labeling service, and this is kind of what I'll be spending the majority of time talking about in terms of how do you build a proper platform that can annotate high quantities of data with high quality results as well. And then the other part of our business is model building. So we have a lot of experience building deep learning models, for the most part focused on computer vision. So I'll be happy to answer any questions at the end as well, kind of around what's required to build models successfully, as well as how to label data in a way that's allows you essentially to build businesses around AI.
Great. So let's dive into the first bit, which is really what does matter when you try to run an AI project. And although people usually talk about, is it, are you using a convolutional neural network or recurrent neural network or, Gaussian mixture model, it's actually almost never the algorithm that defines the success of what you're trying to do. So if you look at the value predicted of the AI market by 2030, there's predictions of around $9 trillion to the global GDP and a further 6 trillion in knock-on innovation, which is a huge, huge potential market, and it's one that really no one could ignore. What's fascinating is the fact that the knock-on technologies offer so much of a percentage of sort of further GDP, and this is something we're going to come back to. But if we keep drilling down a bit further, we talk about data science and sort of AI, but in truth, there's three things here. There's the hardware that allows you to run the machine learning, the data engineering to supply it, and then the data science itself. Data science itself machine learning is just one part of it. And when we talk about data science, we mean the way of looking at business or academic questions and turning those into data questions. And even inside machine learning, the model we talk about is actually only one part of it. But what is a model? Well, it's easy to talk about it as you input something, you input some data, you make some assumptions and approximations, and you build a model around it, and you have an output. And in truth, unless you're a hardcore data scientist, you don't really have to worry about the middle bit. What matters is you understand what's going into your model and what's coming out of it. So it's about what data you have available and how you want to apply it later that defines the rest of it. Effectively, those are the two things that define your strategy. Another way of saying it is garbage in, garbage out. If your data that goes in is poor, your model's going to be poor. It's only as good as the data that it's given.
Yeah, thanks. And here's a kind of another example. This is based on our experience at Hive building models ourselves. And this slide presents a rough ballpark of kind of the investments that is required, both in terms of dollars as well as hours for labeling these type of images. So, for instance, one of our flagship models is our moderation suite, and for that model, we've actually labeled more than 2 billion images. So that scale is quite significant, and if you haven't labeled before, you might not necessarily understand what that means, but we're talking about an investment of $30 million essentially just on that labeling effort alone. So this is kind of the rough scale of what's required to really build a what we would consider kind of a production level machine learning model. So you can't build these kind of models with a dozen images or a few hundred images. You really need scale here. So that's kind of sets the stage for some of the things we discuss later about why data labeling and data is so important. And this kind of touches on that point as well, is that the best machine learning engineer in the world will not be able to do anything if they don't have data. The deep learning models that are being built today really rely on large quantities of well-labeled data, and that's kind of their how you scale those models in terms of their recall and in terms of their precision is feeding it lots of data. They're very data hungry, and that's what we've really found to be kind of the key differentiator between a mediocre model and an excellent model is the amount of data that you can input.
So this, just to reinforce it, generally when you run any kind of data science project or research, most of your time goes into data preparation, which is a huge waste of data scientist time. Often these people are rare, hard to find, highly skilled, and they're spending most of their time doing data engineering, data preparation. But what sort of inputs are we talking about? Well, there's a couple of ways you can look at it. Sometimes they're what's called naive attributes, so they're just information, sensors on a production line. Sometimes they're temporal or sequential, so it's what a sensor's read during the day, or maybe across a certain down a production line instead. Spatial ones tend to be either images or things like satellite images, anything that has some sense of space or distance. And then reward systems, which tend to be reinforcement learning. On the flip side, the outputs you get from these models are either identifications, so a way to say, this image has a dog in it, this is of this type, this is of that type. Maybe it's calculation or a regression, where we take a load of input data and we want to calculate something out from it. So maybe a credit referencing company wants to take in information about a person and calculate a credit score. Maybe it's an action in the way that you want reinforcement learning to work with robotics to move an arm or learn how to work. An image segment is a variation on identification where you can say this part of an image is a dog rather than the image has a dog. Or representation, which is to do with often using self-driving cars. I understand that this image shows the front bumper of a car, therefore around the side of this object will be the side of a car. The last way we differentiate about these inputs and outputs is the idea of how many labels you have, touching back on Nick's points. So if we have a load of data and we have the answers for each of those, so maybe we have, going back to the images, we have a load of images and we know this one has a dog in it, this one has a cat in it, this one has a dog in it. For every single one, it's very easy to do that data science. This is what we call supervised learning. On the other side, we have unsupervised learning where we have no labels. And when we have a few, it's what's called semi-supervised. Generally, the fewer labels you have, the harder it gets. Then there's also reinforcement learning, which is to do with the feedback from the environment. That's usually based on sensor readings for reinforcement learning, which is not something we're going to touch on too much today. But in terms of defining how inputs affect your strategy, label availability is one of the biggest factors in deciding how you go. There's also an assumed cost associated with this. So the easiest, most successful, most reliable models do tend to be supervised models. These cost a lot more to prepare, whereas your unsupervised may have less data prep required, but are much, much harder and less trustworthy. So there's a trade-off here. There's another angle to this as well, which is understanding what really brings value to any analytics, whether this is data science or even business intelligence or just simple statistics. And it comes down to the concept of what's called a data desert, where if you have a large database with only information about one entity, it's like grains of sand. You put them all together, you don't have any variety, you don't have any, you know, it's all the same. You get no value from it. It's like having, as an example for an energy company that invested in data science, spent 6 months looking into their data sets. And because all they had was information on energy consumption, they said after 6 months, they were confident that when people, you know, in winter, when people wanted to heat their homes in England, the energy consumption went up because they had no way to compare it to, you know, detailed population statistics or perhaps additional weather data or buying data or population demographics. Generally speaking, single entity data set sort of deserts contain very little new value beyond the obvious. Or to flip it round, data diversity drives value. So you want to find something valuable, you decide you want some actionable intelligence. I need to know, you know, solve an academic question or a business question. You wrap that around with machine learning or these sort of analytics. It's not as simple as that. Behind that is the data that you trust, and you've got to identify the appropriate sources to feed that data as well. To give you an example of a couple of implementations for sort of your naive attribute input for data, a great example is sort of identifying manufacturing faults. So if you have a series of sensors along a processing line or a manufacturing line, where those sensors are measuring the products, they can feed into what's called an MLP or multi-level, they feed into an MLP, which will be able to regress or identify or classify this is correct, this is incorrect. For a lot of sort of convolutional neural networks or computer vision, there's huge applications for spatial data for improving the imaging for seismic transects, for oil reserves, for oil exploration. For sequence-based or temporal-based data, recurrent neural networks and their variants are quite effective for understanding the demand for products in the future. So if you're trying to decide how many products should be in your warehouse, how many should you produce, how many you should order, it's very, very powerful. For the more complex reinforcement or genetic folding, genetic algorithms that change themselves and reinforce themselves, using them to understand synthesis pathways for organic chemistry is incredibly powerful as an opportunity. But if I step back from this sort of deep dive in, the things that need to be taken away from this are, from the very beginning, you know, the AI market is growing exponentially and it's an opportunity that can't be missed. The data that goes in defines a lot of your strategy, and a good data platform is perhaps the biggest factor of success for any AI project in the public, private, or research sectors. And the knock-on technologies are worth almost as much as the AI sector itself. To dive into an example of what this looks like, let's have a look at agriculture. So agriculture, generally, you grow a crop, you sow the seeds, you pick the field, you grow it, you monitor it, you harvest it, you sell it, and you start again. And that's worked, you know, relatively well for the last, you know, couple of thousand years. However, it's failing to meet needs now. You know, half of the population worldwide is malnourished, and in the Middle East, average cereal productivity, so that's not total amount, but the amount of grain you get per field, per area, is just over a third of what it is in North America. So where can we change this cycle to make it better? Well, let's have a look at what data we have available, the inputs we can put into this. Well, we know if we're looking at starting a crop, we've got geographical and geological data to understand where the fields are, water sources are, and perhaps soil quality maps. We have weather and climate data to understand, you know, the timing of sowing and also long-term climate decisions on what to grow. And there's agronomic data sets on seeds, growing patterns, soil, anything biological that we can measure. When it's looking at sort of the growing phase, when you decide how do I monitor this, when do I intervene with, if there's a pesticide, how do we spot it, how do we if there are pests or fungus or disease, how do we treat it? When do we treat it? When do we spot it? How do I make sure everything's on track? There's ways we can put in infield sensors. Agronomists, which are farm experts that can go out to a field, can observe it. Drone and satellite imagery can measure it from afar. When it comes to timing of your harvest, mid-range weather forecasting, so weather forecasting across 2 weeks, is essential, as is understanding the commodity market, although that's a little bit ahead of time, to understand when you sell it, which is linked to when you harvest it. And likewise, logistics scheduling. Often farms tend to share equipment, so they need to make sure that every field is harvested in the right order. That's all very well, but there are huge challenges in putting all this together. Because data varies immensely over time and spatially in fields, at the same time, it makes it very complex to capture these trends. Biological factors around farming are incredibly unpredictable. Often the sensors out in the fields don't have infrastructure. They don't have a wired connection. It's got to be satellite driven or cell tower driven. Detail has to be there at every scale. So sometimes information can be collected about a single plant that an expert goes out and observes and measures, up to satellite images capturing entire fields. Likewise, being able to pull in sensor data, which is a single point on a field, and an entire image instead, is very hard to do. And lastly, often if you identify some issue with disease or pest, often there's a window of 2 to 3 days to act on it before it's infected the entire crop. So there are huge time-sensitive responses there. It can't take long to do this processing. It's a huge undertaking. However, being able to pull all these in, again, is this idea that data diversity drives value. The more information you have from different angles, the more you're going to get out of this. But it's a huge task. It's a bit like eating a bicycle. You wouldn't want to eat it, but if you had to, how would you? Well, you start at the beginning, you pick a small piece and you keep going. And likewise here, let's start at the very beginning. So how do we identify what crop, or rather what field we want to sow crops into? So we want to take some of the geographical and geological data to identify, understand some of the climate, and maybe start to talk about the right seeds and what the seeds we want to sow require from their field. Again, we go through this pattern here. What sources of data do we need? How do we find the right, how do we trust the data and validate that it's good data? Then we can start talking about how we feed it into our AI, and then start driving some actionable intelligence from it, which is this area here should be a field. This is a image segmentation product, if you like. But any solution we build there actually starts having impacts on anything else around the farm. So often any solution you have will start having an impact on how the farm interacts with its logistics or its staffing. If we know when to harvest much further ahead of time, that makes it easier to manage having the right people on hand. Or utilities, if you know how much to irrigate. Commerce, so how much ahead of time can you sell? How confident are you for what value? This comes into what's called T-shaped learning, where effectively you have a very deep understanding of the core agricultural problems that has a broad, shallow impact on any adjacent verticals. So let's look at 3 challenges that you'd have to solve. So again, I've mentioned that satellite images and remote sensing images and single sensor sort of points on that map are hard to merge together. However, if you can solve that problem, it can be done. The other one is this idea that as you're developing all this information, you tend to have siloing of data. It's hard to link these different data types and sources together. This has effectively a siloing pattern. And lastly, if you want to start doing computer vision with remote sensing, you need to have a way to start tagging your data, and that's quite hard to do. It's, as Nick said before, it's immensely costly to do this yourself. But if you can solve those, suddenly you have 3 products before you even built your AI, which is you have effective Earth observation sort of data fusion patterns. You have a strong relational data model that links everything together, and a way to securely and accurately tag your land use. And then you're able to start building AI that can recommend maybe this area of land on this satellite image is ideal for a farm placement. And maybe we think you should start with this seed, with this kind of chemical fertilizer to help it, given environmental factors. I'd like to move over to a second case study. Actually, it's one that Nick's going to introduce.
Awesome, thank you. So the kind of the framework here that we should be thinking about is data labeling is I would say, pretty much a strict requirement for any company that wants to build an AI model. Certainly, if we're talking about supervised learning, it's essential. It's essential. So you have to have high quality data, and you have to have a lot of it to really get off the ground. So what in the Silicon Valley, we kind of think of it as this is infrastructure. This is electricity. This is plumbing. You have to have these in place before companies are able to really start making progress. So, if you want to build a robust AI ecosystem, you have to have some of these tools in place. And one of those is a data labeling platform. And in terms of, efficiency for the market, it doesn't make sense for every AI startup or every AI company to reinvent the wheel. You don't want every company, building annotation tools, building, UIs for data labeling, building the data set management platform. It's just not efficient. So really what you want to do is you want to establish one or two kind of key players in the market, and then leverage that to essentially allow the other companies to move much faster and to focus on, their key expertise, and allowing them to build a business that, they're able to offer, some unique solution. So kind of with that framework in mind, I want to talk about what we've done here at Hive. For the most part, we've kind of built a solution here for the US. And for European markets as well. We haven't done too much work in the Saudi markets, and that's because of data privacy. We found a lot of companies in the region are very concerned about privacy. So that's one thing we'll talk about later. Is if companies are not able to use outside services like Hive, then maybe a solution really needs to be built in the region. So as I talk about what we've done here at Hive, I want you to think about, okay, well, how could these learnings or how could these ideas be applied to build something, perhaps similar, but, particularly well suited for your guys' needs. All right. So, this quote I think is relevant. A lot of people have said this, but it's this general idea that, data is so valuable, and it's necessary pretty much to drive business, in the modern age. And that's what we want to look at. We want to say, okay, well, how can we get the oil flowing? How can we plumb it properly so all of the companies that need this data can get it effectively and efficiently? It needs to be properly refined. And it's without it, you'll have a hard time really making much progress. All right. Okay, so this is Hive Data. So this is our data labeling platform. Just kind of as a general overview, we've labeled more than 4 billion items. So that's, across videos, images, classification, bounding boxes. We kind of serve a wide variety of use cases. And currently, as a scale, we're labeling more than 15 million items a day. And, if you think about that in terms of like full-time equivalent hours, that's thousands of hours worked every day, which is like, on average, it comes out to about 3,000 full-time equivalents per day. So if we did have, an office full of employees, we would have 3,000 people working for us. But we operate a distributed model, and there's pros and cons. Happy to talk about that later. But ours is a distributed workforce model. All right. Here are some of the, the type of annotations we offer. If you're getting started with, with machine learning projects, I would say the kind of the places to focus are on bounding boxes. This allows you to build detection models. I would say for the most part, this is the majority of any non-classification models are going to be detection models that are drawing bounding boxes around different objects. The other, obviously very important type of annotation task is categorization. So this is classifying images into different buckets. It can be single select, multi-select. But it's adding labels to images. So I would say those two are kind of like the key places to start if you're going to build an annotation platform. And then there's other ones to follow, you know, key points, lines, cuboids, contours, polygons. I would say they're all a bit more niche. And then segmentation is also quite an important one, but can be a little bit more difficult to get started. So I would, you know, if you're thinking about starting to build an annotation platform or services, I would start with classification and bounding boxes. Those are really the bread and butter for AI at the moment. So, you know, one thing to think about when you're setting up a data labeling platform is, how do you ensure accuracy? You know, what does it look like? You know, you know, might not necessarily be able to, you know, sit in a room and look over people's shoulders and explain, you know, every nuance and review every, you know, unit of work that's provided on the platform. So, you know, one thing that we've spent a lot of time thinking about is, okay, how, you know, if we have 2 million, you know, people working all around the world, how do we make sure that we still, you know, deliver really high quality results? And a lot of that has to go into how we instruct people, how we think about distributing tasks on the platform, and, you know, how do we make sure that the site is sticky as well? We want people to come back day in and day out, you know, because they're able to, you know, earn money and provide, you know, for their livelihood through our platform. So it is very important for a lot of people. Some people definitely do view it as kind of their full-time jobs, while other people will view it kind of more on the gig economy, where they might work an hour or two a day when they have free time. And this is drilling more into how we think about accuracy. So there's a lot of different ways that, you know, companies will approach this, but the one that we've taken is looking at consensus. So, you know, for every single image, we'll send it out to multiple people. So, you know, we'll send out the image to 3 different people, wait for their responses, and then combine those responses into the final result. And we find that this helps ensure high quality results. You know, in case someone happens to get tired and misclicks, or, you know, isn't paying attention, the fact that it's going out to multiple other people will allow us to still return a high quality result, even if one of those people fail. And then there's a number of other kind of performance metrics that we look at in terms of, you know, how a worker is performing in regard to the entire workforce as well. All right. So, you know, this is kind of to conclude this point, but, you know, I really want to emphasize that, you know, a data labeling platform, I think, is integral to build a robust AI ecosystem. So if you want to talk about building, you know, a platform, or, you know, a set of services that can support, you know, hundreds of companies, both large or startups that are interested in AI, data labeling really is critical. So, you know, I think any region or any, you know, city or location that wants to focus on AI needs to think about this first. It's, you know, just like if you're building a city, you need to make sure you have the infrastructure in place before you start asking people to come. You know, no one's going to want to move to a city if there's no electricity. It's the same with AI. You have to have some of these tools in place. And the fact of the matter is, you know, if a lot of companies are not willing to go abroad and seek services, then there's a huge opportunity to, you know, build this service locally. You know, there's a ton of jobs that could be created, you know, both, you know, from, you know, the company that's building the platform, but almost more importantly, from the people that are doing the data annotation. There is a lot of effort that's required to classify these images, to draw the bounding boxes. And there's, you know, a really large opportunity there to create a lot of local jobs. So to pretty much like fuel this annotation platform. So I think that's really exciting.
So to lead from that, this idea of generating local tech jobs is a question also of trying to raise the maturity of the local AI market. On a global scale, there's been quite a significant change in the last few years within sort of the Saudi AI market. A royal decree has sort of accelerated the rate at which Saudi is looking to grow, and it has a much better capability to grow. Compared to some of the others here, you have sort of things like Silicon Valley, which is a huge market, but is almost reaching a plateau point where its capability to grow is diminishing, although its maturity is good. London, I think, is about 2 strides behind there. Saudi Arabia has a huge opportunity here in terms of its maturity, in terms of the staff that it has, in terms of the technology locally that it has, in terms of the innovation that it's looking to develop. However, just growing isn't enough. The maturity needs to be there as well. And that's down to AI strategy, both through smaller and larger organizations and also on a countrywide scale. Now, there is quite a classic pattern when it comes to sort of maturity, or in this case, the excitement around a technology. This is what's called the Gartner hype cycle. There's a technological trigger that starts something, the interest goes through an inflation, and it peaks at a point where it's being used the technology is poorly understood, and it's used for projects that don't suit it, or it's not been well understood enough to be successfully used. A high wave of failed projects leads to confidence crashing quite hard, and it's only maybe 2 years later that it ends up plateauing out into a good, productive, valuable point. The danger is a lot of people tend to try to be early adopters of technology and hit on, adopting things like early AI at the point where it's inflating or it's at its peak. And it may be a 2-year, 3-year difference between a peak and a plateau. It's likely that a lot of users will be adopting at the worst point when it's poorly understood and highly adopted, down to a point where it's being abandoned with very little support. It's an incredibly dangerous point for a market to sort of anchor itself on, especially something as volatile as AI, or let alone any other disruptive technology. There is an approach that should smooth this out, however, and this goes on to the concept of sort of multi-phase maturity. So if you have maybe a novel data set as a trigger for a new product, maybe there's a new satellite image data set that allows you to understand certain urban development patterns better. That can then trigger a new wave of development. That triggers then companies start building new AI products. From that, you're starting to bring in more investment, you're upskilling more people locally, you have a high number of staff. Some of those staff may end up leaving, starting up their own companies, or transferring skills at a faster rate, which drives further innovation. Irrespective, each of these triggers and cycles might be difficult, might be quite rocky, it's very volatile. But on average, if you start considering the knock-on of each of these actions, each of these innovations, you start to find a much smoother, stabler maturity that looks a lot safer to sort of anchor yourself to. Indeed, at every single point, we're seeing each of these peaks starts triggering another one. So you're looking at sort of initial, secondary, and tertiary growth just here, and it will be far more complicated than this in real life. But it all comes down to this concept of knock-on technology. So you can accelerate your maturity and improve the stability of your sort of time, effort, and even investment by trying to maximize not only the product that you build, but how it impacts the rest of the system around it. So if we have a look at those products that we built for the first case study, that strongly relational data model means actually now you can start selling data if you wish as data as a service, which is a highly lucrative model. What about the land use tagging? Well, that's got huge implications for security and civil applications, as Hive has demonstrated. In terms of the Earth observation data fusion, that's got huge implications for academic use and even commercial products. In terms of understanding land use for farming, that can be used as a whole suite of products to encourage uptake of agriculture if needed in certain areas of Saudi. In terms of timing, of understanding when you should time sowing of seeds and chemical input timing, the second AI product that we could build, well, that understands and looks at the environment around it to decide what it's missing. Well, that's a fantastic way to start building an indicator for sort of environmental health and biodiversity just from Earth observation, and one that's calibrated for Saudi Arabia. There are a number of ways that you can sort of take your innovation, take your products, take your success, and go forward with it. There's this idea of spin-outs. So it might be that a company decides to set up a second company just focusing on a particular area, or a spin-up where a person decides to create his own company, a startup in a more traditional sense. There's cross-vertical movement where AI allows a certain product to start being applied to different adjacent verticals. So a petrochemical company may find they develop a chemical synthesis AI that allows them to start moving more into adjacent areas, maybe more materials design, perhaps more into sort of your pharmaceuticals. in terms of skill up as well. So this isn't just about creating new companies, but any major innovation means you'll have teams of skilled professionals that will be growing rapidly, and transferring knowledge from one team member to new ones is going to, on a large scale, have a huge impact on the market, especially over a number of 5 years or so. There's also research feedback that's critical. Being able to take innovation and push it back into research means that very risky research can be carried out with very little, risk, really. It comes down to the concept of what's called tech readiness levels. These are used by a number of governments and a number of major research organizations. Famously, I believe this was developed by NASA, but it has this idea that actually there's three main stages: research, development, and deployment. And within them, there's 3 stages each. Universities are critical for the first lower stages. This is when a technology has only really been proven on a whiteboard or in a lab. However, a large business could never invest in it. It's too risky. We don't know that it works. We don't know that it's proven. So, it's all very well constantly driving innovation on a commercial scale, but that's only going to be going from about stage 5 upwards. To start, keeping this conveyor of innovation moving and sort of the growth of the market accelerating, there needs to be enough research support and collaboration, an investment from 1 up to 5, which often is lacking in a lot of even more mature markets. But no, there's a huge need to identify and encourage innovation and talent. If we look at sort of this talent journey, a bit like the sort of the agronomic growing journey we had before, well, there's a way that you take local talent and you nurture it to grow. And then it has a way to find sort of new capabilities and development. And finally, how do you support that and encourage further growth? So if we look just at the first stage here, so you have local AI talent and you want to grow more. So fantastic. How do you encourage skill transfer there? How do you give access to experts so that can happen? How do you, even better, to accelerate skill transfer when there are major AI projects? How can you make sure that those are local led developments, not just foreign experts parachuted in that leave once the project's done with little skill left behind? Once you have that larger pool of AI talent, how do you then ensure that sustainably sort of propels itself, that it organically diffuses? Even things like meetups or conferences like this one to start propagating knowledge. How do you find sort of interorganizational resources of best practice boards? Again, it touches on conferences here. In terms of facilitating spin-outs, is there the investment there? Are there the accelerators in country to start supporting any spin-outs and spin-ups? And once that growth starts, how do you support them with the investment? Are there networks there for them to support them? Where in the market should they be placed? How do you incubate very early ideas? Once these spin-ups start happening, and then you're getting a fresh injection into local AI talent, again, it starts self-propagating. There are certain pitfalls here. It's a mistake to think you can just parachute a load of experts in and ta-da, it's all fixed. It's important to have support, yes, but if just parachuting in lots and lots and lots of people to make it a large team won't achieve it faster. It's very hard to assess the value and success of an AI product before it's fully deployed. It's incredibly hard to assess. And even worse, trying to understand the capability of your team, it can be incredibly hard, especially when your biggest risks tend to be hidden inside your data. The last one is, it's not enough just to train your market, enough to train your data scientists. They can't stop learning. This is such a fast moving market that they might leave as graduates, and within 2 years, most of what they know is irrelevant, maybe 3 years beyond a certain point. So there needs to be a way to constantly support them with constant and relevant upskilling through training, through sort of professional events. And a big one here, any effective knowledge transfer must be active and targeted. You can't, it's not enough just to bring in experts, consultants, and then just let them fully lead a project. local talent, it must learn by doing, not watching. This sort of segues towards the end of our presentation. It's sort of how we like to work with people. We have a big belief in sort of supporting rather than competing with the capability of local Saudi talent. And wherever we go, we want to leave behind self-sufficient local teams. We are, a small collection of experts. We're not an army of consultants, and we have a network in some of the best in AI and academia. And what we try to do is facilitate knowledge transfer at every stage. And we're looking not only at a data science level, but also a business management and a strategic application of AI. Two more of my colleagues are on call, Hemant and Mark, to answer any questions, any queries. And we also have a wider partner family, including the Hive, who's been with us today. So really what we'd love to do is take you from just being accelerated by a royal decree and to help you catapult up to a sort of leadership position in the world. So thank you, and any questions?
Thank you, Richard. Thank you, Nick. Thank you for this nice presentation. Maybe, Nick, you can share with us, please, how Silicon Valley is able to integrate AI with innovation, and how Saudi Arabia could make such a move in the future. Thank you.
Yeah, great question. I think computer vision is definitely one of the, I think it's seen some of the biggest benefits, from deep learning, which we saw kind of kickstarted with, I would almost call it, the hardware revolution over the last maybe half a decade. As processing power, as GPUs kind of really came to the forefront, that allowed a lot of the deep learning applications to really take flight. And a major part that we've seen there has been in computer vision. So I think the way to really think about it is, is there a problem that could be, highly leveraged from, a large, imagine if you had 1 million people who, perhaps were not, perfectly trained and weren't always right, but they could review any image you could send them. That's how I like to think about, computer vision AI. It's not going to solve problems that a human couldn't, for the most part. It's really about leveraging like scale. So it's saying, okay, instead of having a dozen people in the office review 1,000 images a day, what happens if we could train a model and then review 10 million images a day? What sort of business value could you add there? So I think that's kind of the place to think about is, if you have existing businesses, that are using some sort of human component, how much of that could be made more efficient with AI? Often we don't think that, AI will necessarily like replace jobs as much as make those jobs more efficient. We think people will always have to be in the loop for most problems. If you have 10 people labeling data today, you're probably going to need 10 people labeling data tomorrow. The main difference is, those 10 people could be, 10 times as efficient. And we think that's kind of what's really exciting is the way that, people's human capital can be leveraged and made more efficient. In terms of how to actually build models, it's actually becoming fairly democratized. There are a number of frameworks now that make training and deploying models, fairly easy. For instance, we use one of the more popular ones, TensorFlow, and TensorFlow serving for deploying them at scale. There's a lot of very mature resources now kind of around deep learning that can make it, fairly easy to get started. You can train your own, toy model and in a few hours with some of these courses now that are available. And obviously to create a production model requires a lot more effort, but it's not what it used to be. I think, half a decade ago, you had to be a PhD to train a model. And now, pretty much any data scientist with the gumption is able to at least break in the door. And they might not necessarily be conducting groundbreaking research that's still probably happening in like academic universities and large companies' research arms, but in terms of actually deploying a model that can be used, that's happening in a lot of places. It's definitely becoming much more widespread.
Thank you very much. How possible is it to share your experience with the AI society and make benefit of your knowledge and the training that can be offered and the research that is being done as well? Thank you.
Yeah, no, we're happy to share our learnings, and that's one of the exciting things that one of the reasons to kind of that we partnered here with SAIL is to bring our expertise and our knowledge to other regions and other people that are building this AI technologies. We really feel like there's no need to reinvent the wheel if it's a problem that we've already thought of and we've already dealt with, and we're happy to share that knowledge. We kind of believe in it the rising tide lifts all ships. We're not here to hold all onto like our proprietary knowledge. We really want to kind of share what we've learned, and I think the more the AI field accelerates, the better for everyone. So that's kind of the position we've taken.
One last technical question to Mr. Richard, please. When it comes to data segmentation and data labeling, what is the best algorithm that can be implemented when it comes to this, out of your experience? Thank you.
You've asked the wrong person. I think Nick's better for this one. My specialism is in signal processing, so I love my recurrent neural network work. Nick, are you good for this one? Image segmentation questions?
Even in signal processing, I've been working with signal processing. So generally speaking, I would like to hear what kind of labeling algorithm do you suggest?
Well, I spoke on one yesterday that I've been really excited over, which is these invertible residual networks. What's amazing is an ability to take unsupervised or semi-supervised data and find better ways to represent them. So often a lot of unsupervised data is quite chaotic. It's very, very hard to label it. These sort of residual networks find ways to re-represent data rather than finding answers, derivations, outputs from them, to a way that we could then cluster much, much, much better. We cracked quite a hard problem in cloud classification this way. And I think that's what's changing, or will change a lot of how machine learning works in the future, is this idea that maybe we don't need an answer out of machine learning. Maybe we just need to find a new representation of what we know and then find patterns from that. I think that's going to be revolutionary. It's taking a while to get a hold of.
Thank you. Thank you very much. What about you, Nick? Would you like to add something, please?
Yeah, I would say it really depends on the type of problem. If there's a number of different methods for like classification models, but detection models are different. Semantic segmentation models also require different architectures. Our machine learning team has, I would say we have kind of several that will be our go-to, and we'll build off of training models off of like different checkpoints from existing solutions. But then we'll also look to kind of academic research and try to implement new ideas as well. So it's a little bit hard to say. I don't think there's any necessarily like one algorithm that will be the best. There are some that are good for different things. If you're doing object detection, there are certain algorithms that are good for that. But if you're doing like image classification, there's other things that would be better suited for that approach as well. Yeah, it's fairly varied, but there are like, there are architectures already that are in place. You could, for instance, take ImageNet and, use that as a starting point and train a model, fairly easily, and it will probably do decently well if you give it enough data.
Thank you very much. Thank you for your time. Thank you for your answer. I know this is a hard question that easily could be answered, but maybe you can suggest some of the books that you think is good, or some of the materials that you think would assist people who are working with segmentation and labeling for the time being.
Yeah, we have some kind of internal resources that I know our machine learning team uses to onboard our new hires. I can see if that's something we can share. I think it provides some sort of general frameworks about how to think about AI, certainly like at Hive, but then it also goes into some more details about the type of solutions that we kind of have implemented as well. So yeah, I'll see if we can share that after the presentation.
Thank you for your input. Thank you very much. Thank you, Richard. Thank you, Nick. Thank you, SAIL team. Thank you, Hive. We are happy to have you with us today, and hope to meet in the near future with other workshops and with more interesting work and research. Thank you very much.
All right, thank you.
Yeah, thank you for the opportunity.
Thank you. I don't think that we have any more questions now, so I guess we can just leave and wait for our next meeting with you in the near future, and the people who are waiting for the next session. Thank you.
Thank you.
All right, thank you all. Take care. Bye.